Welcome to Module 2 of Career Era Postgraduate Program, Cybersecurity. In this last module, you learned about cybersecurity is and why cybersecurity is important. Today, we will discuss how computers connect with each other by beginning to illustrate the vulnerabilities in various configurations. If you and I were to stay at home indoors, we probably never would catch a virus or have an unwanted guest in our home. But we are a social society and connecting our computers to the World Wide Web. Here's a quick background on who I am. You're welcome to connect with me on LinkedIn and feel free to ask me any IT related questions. Like here in class, if I don't know the answer right away, I'll ask one of my smart friends and get you an answer. I've been an instructor for a little over 15 years. Most of that time, I've been working in the DoD on computers, doing information technology. And most recently, I was selected from our battalion to be the supervisor for the network infrastructure there at Fort Meade, working under the NSA in the Cyber Command. Today, we will look at three major common computer networks. Then we will look at network topology, which is a fancy way to say how the computers are configured and talk with each other. And then we will introduce the 7-layer OSI model. This OSI model will continue to provide a mental framework for us to discuss elements of networking with other cybersecurity models and referencing in the process packet transmittal is occurring. Multiple different network types, we will discuss 4 of these. The wide area network, known in the industry as WAN, metropolitan area network, MAN, local area network, LAN, and a personal area network. Starting with the WAN, that's the internet. Moving into the metropolitan area network, the MAN, cities such as Moscow, New York, and in Hong Kong are now offering free Wi-Fi for all the residents. They find that it helps people stay connected and increase productivity. At your home, in your office, or a small group of buildings is where we find the LAN. This could be a single router. PAN, personal area network, that might be your smartwatch connected via Bluetooth to your phone. Two main ways to look at network topology. One is your physical, things that usually you can touch. The other would be the logical. Your physical, as seen here in the bottom left-hand corner, is the RJ45 connector going into a port. As the name suggests, refers to the physical connections and interconnections between nodes in the network, the wires, cables, and so forth. Logical is a little bit more abstract and strategic, referring to the conceptual understanding of how and why the network is arranged the way it is, and how data moves through it. Within this physical or logical topology, there are multiple different ways a topology could be configured. We'll look at 3. The first being the bus. The bus topology orients the devices on a network along with a single cable running in a single direction from one end to the other. This is known as half duplex. An advantage here is cost effective. The disadvantage is it's vulnerable due to a single point of failure. Like the bus topology, the star also has a single point of failure. The star topology is a more common configuration because it has more stability and security. Advantages include the devices outside the center node can be added, removed, and modified without taking the entire network offline. The disadvantage, as soon as that central hub goes down, the rest of the network cannot function. Mesh topology is fully connected. These routed nodes use logic to determine the shortest distance from source to destination. If a mesh topology is flooded, the information is sent to all the nodes within the network without the need for routing logic. This can become very congested and a real problem for the network engineer. An advantage of the mesh network is it's reliable, it's stable, and no single device, including a node, going down can bring down the network offline. A disadvantage, very labor intensive to connect and configure. The cost of cabling can add up fast when adding additional nodes. Now we're going to look at Now we'll look at the OSI model. This is 7 layers. It's a mental infrastructure, a way to understand, troubleshoot, and talk about what's happening with computers to other people that understand the OSI model. Starting at the physical layer, that's anything that you can touch, and the Wi-Fi, the radio signals. The medium of the air is considered on the physical layer. The data link layer is stacked on top of that. We'll get into this a little bit more later. Network, that's our routing. We call that layer 3. And yes, routers are included on the routing of the network layer. Transport layer, session layer, presentation layer, and application. The user interacts with the application layer. Discussing the OSI model in a little more depth. Physical layer, we talked about the raw bit streams going over the physical medium. That'll be the ones and zeros. The data link is the formats of the data that is moving on that. That's your layer 2. That's where our switches are located. Layer 3 decides which of the physical path the data will take. That's our routing. What route does the path take from one location to the other? Transport layer. Real quick, TCP, ensure that it gets there. It'll check and double check that the whole package gets through. UDP, more like a video feed. This is going to be sending it there without concern of did all get received, but this is great for real-time transmissions. Session layer maintains the connection and is responsible for your ports and sessions. We'll talk a lot more about the common ports and even memorize some of the ports used within the IT world. Presentation layer ensures that the usable format, and this is where the data encryption occurs. In the application layer, like an app on your phone, the application is the human-computer intervention. That's the interaction, how we interact with the computers. I look forward to working with you along your process, but as I looked here at the CCNA 200-301, that's the most recent Cisco Baseline Associate Test, I want to share something that happened to me about 12 years ago. I was in Afghanistan and we were studying. I even went to a boot camp to learn the CCNA. But here's the problem. I learned to pass the test without getting that next level of understanding. Yes, memory banks are out there, and yes, especially through the lower level Cisco or CompTIA courses, there's ways to understand this is the answer for that question. But I ask for you and I to go through a journey where we understand the why. The why do we do it this way? Why does a computer interact with this other computer this way? Once we understand the why, then we'll be able to really go through and troubleshoot and help other people. So let's continue our cybersecurity journey together. I look forward to learning and working with you in the near future.